Good morning, dear friends. I am Dr. Reginam Linus from School of Electrical and Communication Sciences at JSPM University, Vagoli, Pune. The last couple of lectures, we have learned how the electrical machines can be modeled when the stator variables are as such and the rotor variables are moved to the stator. Therefore, where the rotor variables are fictitious and the stator variables are as the same as the natural reference frame. Accordingly, we have learned the entire modeling in the stator attached reference frame where all the variables of rotor are fictitious. Also, we have seen how one can write this matrix without doing the lengthy derivation by observation. So in this today lecture, we are going to learn about if the stator variables are fictitious in the rotor, how one can derive the equation, and from this how the stator variables are, how the rotor variables are, and how the final matrix in the DQ reference frame. So in this case, the rotor attached reference frame. In the rotor attached reference frame, where the stator variables are fictitious, are fictitious, and at the same time the rotor variables are as such. That means if these variables all are rotating in the rotor speed, the rotor variables, all the stator variables, we are transferring to the rotor variable. So now we have learned already in this lecture 31st and 32nd lectures, we have learned that what is mean by, I can recall from this, what is mean by voltage equation in the alpha beta reference frame. That is nothing but R alpha beta naught into I alpha beta naught plus L alpha beta naught into d by dt of I alpha beta naught plus G alpha beta naught into I alpha beta naught into omega r. So we have seen G alpha beta naught is nothing but this is entirely the speed EMF term. This is the rotor resistance term, resistance drop term, and this is the voltage across the inductance. So we are now moving this, as I said already, we are moving this variables to the rotor, all the stator variables to the rotor. So what happened? Assume the variables may be voltage or current, voltage or current. So for our simplicity, I am going to take this variable as f. The same thing I am repeating the variable, I am repeating when I was explaining about the stator attached reference frame. So now we can, as I said, stator variables are VDR, that means direct axis variable of the rotor, and quadrature axis variable of the rotor, and zero sequence axis variable of the rotor, zero axis. So these variables I am taking as such. That means all the variables are same as like the in alpha beta reference frame. So we can multiply this with the unit matrix 1 0 0 0 1 0 and 0 0 1 into that variables are in the natural two-phase reference frame. That means F alpha R, F beta R, and F naught R. Now at the same time we are moving that stator variables to the rotor variable. For our simplicity, I am going to draw that diagram in a clear way. This is the alpha x alpha s stator variable, and this is the beta s stator variable, Then now we are moving, this is the rotor. Once again, I am repeat whatever I have explained previously in the lecture 31. So this is the rotor and the rotor axis are 90-degree displacement. So now this is the 90-degree displacement. So this is nothing but alpha r and beta r. So where we have the stator winding, that voltage is V alpha S, and the rotor winding, stator winding voltage V beta S. Similarly, rotor winding voltage as V alpha R and rotor winding voltage as V beta R. The angle between these two rotor and stator is theta R. Now, as I said already, we are moving the stator variable to the rotor. We are moving the stator variables to the rotor. So, we can write, so now in this case, we are this all rotor stator variable. So similarly, the stator variable is moving to rotor. So in this case, the rotor variable or stator variables are fictitious in the rotor. So the rotor variables are as such. That's why in the previous equations I have taken only the rotor variable in the synchronous in the rotor DQ reference frame are same as the rotor variables in the alpha beta reference frame. Now, when we move this equation, when we move these values in the, let me draw the equations. Sorry, we can draw the waveform in the different way. Is we have two axes as such, and uh, now we can say this imaginary axis as we can draw in the red in color. So this is your alpha beta s axis and this is your alpha s axis. Now this is fictitious, right? So now this is the new axis I am going to draw, that is the rotor axis. Rotor axis is here and this is perpendicular line. This is the perpendicular line. So this is our new axis. I already told you alpha r is same as dr, right? So we can write here dr and qr. So the windings in the dr, I can write vdr, voltage we will apply. Similarly, qr we will apply here, vqr. At the same time, this beta I am transferring to the rotor. So now I can draw this here, the winding. So this voltage is nothing but VD. This is fictitious, right? So that I will write it VD SF, fictitious. Similarly, this is moved here VQ SF. That means F is nothing but fictitious. So I hope you understand. Now the rotor variables are as such the same. Even I can use the same blue color. At the same time, the stator variables are moved to the rotor. Therefore, in the rotor, in this reference frame, the stator variables are fictitious. So accordingly, if you do this, we can draw, this is this angle we have already noted as theta. We have added this angle as theta. So now I am going to write the fictitious variable. Already I have given the stator rotor variable here as such, right? So now I am going to write that fictitious variable. I can write IDFF and we can write VQSF and F naught SF. So these three variables. This is can be the voltage or current, whatever may be. You can choose any one, voltage or current, right? That's what I have chosen the variable as F is nothing but we can write now with respect to F alpha S, F alpha S, F beta S, and F naught S. F alpha S, F beta S. So now this VDSF means nothing but new winding here. This is, I can say, the DSF, right? So with respect to this alpha S, this angle is theta R. Therefore, I can write here cos theta R. FDSF is nothing but cos theta R into F alpha S. Then F beta S. F beta S, what is that? F beta S from DSF to DSF is this axis and beta S is this axis. So therefore this angle I can write it as 90 minus theta R. Therefore we can write cos of 90 minus theta R, that is nothing but sin theta R, and this again the final zero axis is automatically it will be 0. Then we can have VQSF. VQSF is here. VQSF, sorry, FQSF is here. So FQSF with respect to alpha S axis, what is the value? Cos of 90 plus theta. So we can write here now minus sine theta R, and we can VQSF and F beta S, sorry, FQSF and F beta S. So FQSF is here, beta F is this winding. So this angle will be theta R. So we can write cos theta R, and with respect to zero axis 0. Then we will have zero axis having the same. If this 2R will be 0, this will be 1. So this is the new matrix for conversion of stator variable to the rotor variable. So with respect to this all the values, I can form F matrix. In the previous rotor attached reference frame, sorry, stator attached reference frame, we have written as E matrix. Here we are going to write it as F matrix. So in this F matrix, values will be first the stator variables we are changing. So this is cos theta R and sine theta R and 0, then minus sine theta R and cos theta R, then 0, then 0, 0, 1. At the same time, rotor variables are as such, right? The rotor variable is what? Rotor variable we have already written, unit matrix. Therefore, we can write here the unit matrix is 1, 0, 0, 0, 1, 0, then 0, 0, 1. So this is the entire matrix, right? So the remaining variables are zeros only, 0, 0, 0, 0, 0, 0, and 0, 0, 0. Similarly, here also 0, 0, 0, 0, 0, 0, then 0, 0, 0. So this is the conversion matrix. We have to use it for the conversion of alpha beta to conversion of stator variables to the rotor variable. So now let me write it in a short way. We can have the small 2 cross 2 matrix. I am taking this entire this matrix as H matrix, and this is already we know this is the unit matrix U, and this is the zero matrix, this also a zero matrix. So we can write now this is H matrix 0, 0, and unit matrix U. So this is if then in as we have seen in the last stator attached reference frame, sometimes we need to take the conversion matrix inverse also, right? So in this inverse, what we can do, we can have this inverse F inverse F matrix I have already written. What is H 0, 0 unit matrix. Therefore, F inverse is nothing but F transpose. F inverse is nothing but F transpose. That is nothing but H 0, 0 unit matrix, the whole transpose. So that is the value will be H transpose 0, 0 U transpose. So this is the F inverse. So now we are going to substitute these values in the above equations. What is the equation we have already written? This equation. In this equation we are going to substitute. So now already told you the variables are maybe voltage or current. Then now we can, for simplicity I can write it here. V alpha beta not equal to F inverse into V dq V dq not F into R. That means stator is fictitious. Previous cases SR, SF I have written. So their case rotor is fictitious. Here I have written stator is fictitious. That's why FR. Similarly, I alpha beta not equal to F inverse into I dq not in dq not fr. So this is what we are going to substitute in the first equation. Okay. So v alpha naught we will substitute here. V alpha naught we will substitute here, and I alpha naught will substitute everywhere. We will, wherever this voltage and currents are there, we are going to substitute. So hence, this first equation becomes, we can write F inverse into V dq naught dq naught fr, that is equal to r alpha beta naught into F inverse. I am going to directly write F inverse is nothing but F inverse is nothing but F transpose, right? Already we have seen. Therefore, we can write it here F transpose R alpha naught into F transpose into I dq naught Fr plus L alpha beta naught into P of F transpose into I dq naught Fr, then plus G alpha beta naught. So this G alpha beta naught into here we are going to substitute I alpha beta naught. So I alpha beta naught already we know that F transpose into I dq naught Fr plus Fr into omega r. So now this is the, we are going to do the lengthy derivation for this. So from this we can write it as we are going to the F transpose, we are moving to right side of the equation. So F transpose will be go moving to right side of the equation. That is nothing but F transpose of inverse. F transpose of inverse is nothing but F transpose the whole transpose, that is nothing but F. Therefore, we can write, let me take this equation as, so this T is nothing but, so P is nothing but, we can write this P is nothing but d by dt. Already we know this. This d by dt. But f is having, f is the function of theta, right? So how we can derive this now? We can write it, f. Uh, First, let me explain how I am transferring F transpose to this side. So already we know F transpose inverse is nothing but F. Therefore, B D Q naught F R equal to F transpose into R alpha beta naught F transpose, not F transpose. So is F transpose inverse is F alpha beta naught into F transpose and I dq naught Fr. This is one variable, don't confuse it. It is so lengthy. So otherwise from henceforth I will make it this as I dq Fr. I dq Fr. So we can have it right I dq Fr. That means stator is fictitious, rotor is as such. Plus here we can write F into L alpha beta naught into P of F transpose into I dq naught dqfr dqfr plus F into G alpha beta naught F transpose I dq fr into omega r. Now we can write this already. We know the P is nothing but d by dt, but f is in the function of theta. So now I am modifying this equations, that is f into r alpha beta naught f transpose I dq fr plus f into L alpha beta naught. Then I am differentiating this f with respect to theta, right? So I can write it now. Otherwise, first I will split this into UV form. That means what? P of F transpose into I dq Fr plus UV form. Then we are differentiating. This is common, right? So differentiating um, F transpose into P of ID Q F R, okay, UV form plus F into G alpha beta naught F transpose I dq F R into omega R. So now we can separate this all the terms. Before that, here I already told you f is in the terms of d theta. F is a function of theta, but current is in terms of with respect to time, right? So I can modify this equation as f r alpha beta naught and f transpose into I dq fr plus f alpha beta naught into p of f of t f transpose, right? F is the function of theta, therefore I will write d by d theta of f transpose into I dq fr into d theta by dt plus f L alpha beta naught F transpose. I am multiplying this to second term and P of I dq Fr IDQFR, then plus the final variable F into G alpha beta naught F transpose IDQ FR into omega R. So now we already know this d theta by dt is nothing but omega. Therefore, we are going to segregate everything. That is v dq fr is nothing but fr alpha beta naught f transpose into I dq fr plus then this is one speed term and this is the one voltage inductance term, right? So I will write f L alpha beta naught f transpose P of I dq fr. So now this term is over and this term is over, then plus I can write f L alpha beta naught FL alpha beta naught into F transpose FL alpha beta naught uh, differentiation alpha beta naught and d by d theta of F transpose into IDQ FR into IDQ FR. Then now this term is over. Then final term plus F G alpha beta naught F transpose into I dq f r the whole multiplication into now omega r. Now we have these three terms are available. So now I am going to make this term as the resistance I dq fr. That means stator is which is yes and rotor is such as the rotor is as such and it is in the rotor in the reference frame. What is the resistance, right? Then this is nothing but the inductance. So inductance is nothing but L dq fr. Then this term I will write it as G dq omega, sorry, d gq uh, fr. So now I am going to write the final equation as V dq fr equal to R dq fr into I dq fr plus uh, L dqfr into P of I dqfr, then we can have, I will take this current also outside. Okay, current is also common factor and the current is also I will take outside. So we can write plus G dq fr into I dq fr into omega r. So this is what we have derived the final equation. Okay. So now the next step is we have to find out each values and take and make the matrix.